Okay, welcome back. Just like we saw with direct variation, we can use the relationship of two variables that are inversely related to come up with a formula that represents or describes that relationship. So just like we saw with direct variation, that the two variables that are directly related to each other, or that vary directly, the proportions, right? The proportion has to be constant, right? In inverse relationships, when we have two variables that are inversely related to each other, then we know that, again, as one goes up, the other one has to go down. As one goes down, the other one has to go up, okay? So in that case, we know that the product of those two would have to be constant, because if we have a product that's constant, then as one factor goes down, the other factor has to go up in order to keep the product the same. So in this case here, that's why we get that the product of xy is constant. So if the product of xy is constant, if y varies directly as x, or if x varies inversely as y, or y varies inversely as x, then we know that the product has to be constant, okay? So that's one of the results, okay? Now, given that, now we have a way to find the constant of inverse proportionality, okay? Which is what we call k in this case, okay? So how do we find it? Well, just like with direct variation, when we're trying to find the constant, we have to identify a pair of inversely related data with known values. And then what we do is we write the related pair as a product, right? And so basically what we're doing is we're sticking it into this formula and multiplying the product to find the constant. That's it. That's all we're doing. If we know that x and y are inversely related, then we know the product of those two values must be constant, and that's how we find k. That's it. Take care.